I don't care.
Thank you for attending our Indiana-Michigan Power webinar, Energy Efficiency Benefits. My name is Chris Guthrie, and I am the host of today's webinar. We will be sending everyone a follow-up email within the next couple of days that will include a PDF of the PowerPoint presentation materials and the playback link to the recording of today's webinar. Because of the large number of attendees, we will only be accepting written questions from you today. Please submit any questions by typing them in the chat or Q&A windows on your screen. We will take some time at the end of the presentation to answer your questions, or we will follow up with you separately after the webinar has concluded. To expand the presentation to full screen, click on the diagonal arrow icon in the top right corner of the slide. We will be conducting polls during the presentation. A polling window will appear on the bottom right of your screen, and you will be asked to answer one or more multiple choice questions. We really appreciate your participation in our polls. I'm opening our first poll now. Please be aware that you are not the only participant today. The names of other attendees are not being shown to you for reasons of privacy. Now let me introduce you to today's presenters. Mike Carter is a senior energy engineer and has a BS in engineering and an MBA degree from The Ohio State University. He has worked with various EPRI centers supporting electro-technology applications and spent 10 years conducting due diligence for technology commercialization. Mike is a certified energy manager from the Association of Energy Engineers. He writes articles for the newsletter, answers Ask an Expert inquiries, and develops webinars on energy topics. Also joining us today are subject matter experts Jason Whitman and Bob Bornacue. And with that, I'm going to turn things over to Mike to start the presentation off for us today.
Well, thank you, Chris, and welcome everyone to our webinar. This is actually the fourth in a series of 5 webinars that Indiana-Michigan Power is offering to its customers this fall. We'll highlight the next and last one at the end of the presentation today. But if you've been considering an energy efficiency project, today we want to encourage you to consider all the benefits of an energy efficiency upgrade in order to financially justify that investment. And typically we focus on just the impact on the utility bill. We'll call that benefits bucket number 1, but there's actually 2 additional buckets of financial non-utility and non-financial benefits that may actually provide far greater value than the utility bill savings alone. So we're really going to challenge you today to rethink your justification of energy efficiency upgrades, and we're going to review those other benefits and quantify them as best we can for several business segments as we show over here. We'll also discover why simple payback's really the best financial tool, and we'll look at alternatives that better capture the true financial value of energy efficiency investments. And then we'll finish by just addressing some common but false objections to making energy efficiency investments. I think this is going to really help you be able to justify, particularly financially, energy efficiency upgrades maybe that you've tried in the past and just didn't quite cut the mustard, as it were. As I mentioned, utility cost savings are traditionally the prime justification for energy efficiency investments, but they're not without their own challenges. We recognize that utility expenses aren't a huge percent of your operating expenses, and you can sometimes have a pretty significant investment in order to achieve those energy efficient savings. But another source for that's financial payback, so it's real dollars, it just doesn't apply to your utility bill, are the non-utility cost savings. DNV-GL undertook a commercial facilities pulse survey of nearly 500 commercial facility managers across the U.S. Not too long ago, and this survey analyzed the current patterns of energy management and efficiency investments in large and mid-sized commercial facilities. And what they discovered was that 84% of survey respondents who reported having taken steps to save energy reported at least one positive business benefit, such as lower operating costs or higher worker productivity. And there's actually quite a few benefits, and I think we really work hard to look at if there's some studies that have been done to justify monetizing these benefits. We'll share those with you today. But these upgrades also result in what we call non-financial benefits that still have great value, but they're just difficult to quantify in dollar terms, at least early on. It's, such as more comfortable employees, meeting energy codes like ASHRAE 90.1. Do you think that a better lighting, better temperature control, airflow will retain and maybe even attract new employees? There's other codes, this one in healthcare, that requires proper pressure relationships, certain number of air changes per hour, certain type of filters efficiencies, and your upgrades are going to help you meet that as well. If you're a restaurateur, you probably know that the dining ambiance is really important, and energy upgrades can support that. And if you're just a retailer with products on the shelf, we're going to show you evidence that increased lighting anyway will produce higher awareness of products and brands that are on display. It's kind of summed up in this, what we call the energy wheel, that has the utility cost savings, just one benefit. It lists all the non-utility cost savings, so still financial, and then some non-financial benefits as well. The bottom line is we really shortchange ourselves if we only consider energy savings bucket number one here when justifying an investment in energy efficiency. So let's apply this to several business segments. We'll start with healthcare. We'll consider the energy efficiency benefits for a 500,000 square foot hospital, beginning with energy savings bucket number one. And if you run the numbers on the typical 500,000 square foot hospital, assuming a certain savings amount that's reasonable for HVAC and lighting upgrades, you're going to see savings on the utility bill of $140,000 a year for HVAC, maybe $150,000 per year on lighting. You can come back when you get a copy of this and study that a little closer, but I think you'll find those are very reasonable assumptions. We also know, though, that work performance and thermal comfort is highest at approximately 71 to 72 degrees Fahrenheit, and as the indoor air temperature rises way above that or falls way below that range, the people's performance decreases. On average, it's about 0.3 to 0.4% for each degree change in temperature away from those optimum set points. And Professor Seppänen studied this in a study, Effective Temperature on Task Performance in Office Environments, and he also studied this for ventilation and performance in office work, and concluded that you'd save several $700 per year by achieving better temperature control and better indoor air quality as well. And then you have to think about how buildings affect our health, and buildings do. And Vivian Lofness at the Carnegie Mellon University Center for Building Performance and Diagnostics has worked very hard on this issue, and she found that the annual direct medical costs of building-related health conditions like headache, respiratory, that kind of a thing, per employee is about $745. She also determined that the total equivalent work days lost to building-related health conditions is estimated to be 10 days per year, amounts to about $2,000 per employee. So the total being about $2,700 in terms of the cost for an unhealthy building. Now, if you could cut that by, say, a third, you're going to be saving close to $900 per employee. And there's also evidence that a green building, a very efficient building, upgraded building, can reduce maintenance costs on the order of about 10% or about 25 cents per square foot. So let's take a look at this comparison. We talked about utility cost savings for HVAC alone was about $140,000. We make a case that the non-utility benefit, still dollars, but just in this second bucket is about $850,000. How did we come up with that? Well, we were conservative. We said, well, let's say that employee productivity improves 1%. You get 5 more minutes a day of work out of someone, or 22 hours a year. What's that worth? Well, if you look at the average cost of an employee and 1% of that, it's about $150 per employee per year. Also, if we just are conservative and only take half of that estimated $900 per employee healthy building benefit, reduce the cost of sick building type impacts by one-sixth, then you're going to save about $450 per employee. And we tacked on some savings from building maintenance totaling $850,000. You might say to yourself, well, that's really tough to believe. And, yes, you sound like you were conservative in some of these estimates. And I would say to you that, okay, let's say we're twice as much as is maybe more justifiable. So we cut this to $400,000. We're still tacking that on to only $140,000 of utility cost savings, and that's going to be a whole lot easier to justify than just the utility cost savings alone here from bucket number 1. That's just HVAC. Let's look at the effect on a hospital for lighting. And there was a 2015 study of patients on a dementia ward that was conducted by Mariana Figueroa, who's professor at the Lighting Research Center at Rensselaer Polytechnic Institute. In fact, she just became head of that group, got a promotion there. I've actually talked to her about some of this when I've met her at some of the industry lighting meetings. And she discovered that patients who use a light table kind of in the commons area had a 10% increase in sleep efficiency and had a significant reduction in symptoms of agitation, depression, et cetera. And research at Carnegie Mellon's Center for Building Performance also identified 9 case studies that provided a link between improved lighting design and individual productivity gains with a median improvement of about 3.2%, which would account to about $1,600 per employee per year. And so there's a lot of evidence that lighting upgrades can positively impact hospital health, their business goals, as well as improve employee productivity. Another thing that's affected by lighting is errors that people make, or the degree of quality. It's known that about 44,000 Americans die in hospitals each year as a result of preventable medical errors. And Bruce Pyenson, he conducted a study that determined the incremental annual cost for what he called preventable adverse drug events, or ADEs, that results from injectable medication errors is around $600,000 per hospital. This study was called National Burden of Preventable Adverse Drug Effects Associated with Inpatient Injectable Medications, conducted in 2012. And also another researcher, Gracia, who conducted a study called Psychosocial Factors, Workload, and Risk of Medication Errors, determined that pharmacists that used task lights to increase the illumination at their job had a significant reduction in prescription filling errors. So there's evidence for that impact as well. If we put that together for lighting like we did for HVAC, again we see that utility bill impact, the bucket number 1, $150,000. Now we're looking at non-utility benefits of $570,000, and we just did a reasonable 1.5%. I think we saw earlier the study said it would be more, 3 or 4%. And we'd say, well, let's reduce the error reduction by 1/4, and that adds up to several times the amount of impact that you see on the utility bill alone. And you'll see this is a common theme as we go through here. How about manufacturing? Are there any reasonable and financial benefits outside the utility bill for energy efficiency upgrades in manufacturing? Well, there are, and there was a white paper by Pye and McCain listed here, show their names, that listed all of these possible non-utility cost savings. Increased productivity, easier to meet environmental requirements, which is a big expense for manufacturers, reduced waste disposal, improved reliability, improved worker safety. And so we'll just focus on two of these, increased productivity and worker safety, and we'll, of course, involve the impact on the building on health as well and see what those look like. So let's just say a 50,000 square foot manufacturing facility with 100 employees, you might see total lighting HVAC upgrades savings about $10,000 per year, not as much as typically you might see in commercial buildings of the same size. But improvements in temperature set point control and increased airflow and improved lighting can certainly increase worker productivity by this 1% assumption that we're making. And that translates to increased output per employee of, say, $250 per year on average. I don't think anyone would, I've heard several cases of factory plant managers saying, well, yeah, if we improved our lighting and, temperature control, et cetera, you'd easily see a 1%. They're usually saying, 5 to 10%. But if you just said 1%, well, the survey of manufacturers says that the average value of shipments per employee is about $500,000 for manufacturing, and the average profit at a 5% profit margin of that would be about $25,000. So let's say you can improve that by 1%. That'd be about $250 per employee. The other issue is fewer accidents. Workers' compensation rates depend on your safety record and reported accidents. National Safety Council estimates that the average cost of a workplace medically consulted injury is $36,000 in both a combination of the direct medical expenses and in lost time expenses as well. And they estimate this occurs at a rate of about 1 incident per roughly 30 manufacturing workers per year. And so if improved lighting, even that alone can reduce the chance for a worker being struck by an object, tripping or falling, et cetera, then you can see a very significant impact in reducing that cost. Also, there was a Lighting Europe study that was called the Quantified Benefits of Human-Centric Lighting, and they looked at a factory of 750 workers performing repetitive tasks. And what they did was they actually even already had LED lighting, but it was kind of low light levels, so they increased it to about 200 candle power of lighting. That's pretty high. Normally you use about 30 to 50 in an office. And yes, the electricity costs rose about $13,000, but the effect on productivity was that it increased productivity by 4.5%. They saw 1% fewer accidents due to increased alertness and even 1% fewer sick days, and even an extension of retention of staff as well from that study. So let's put that all together and again compare the total utility upgrade cost savings of $10,000 with savings that come from employee productivity, fewer accidents, let's say one less every 2 years, and in our typical 16% reduction in employee health care costs. Again, just looking at the impact of space cooling, not even the heating aspect of it. And you can see that the non-utility benefits, this bucket number 2, again, far outweighs the utility cost benefits for manufacturing. How about where most of us live in office spaces? We could do the same analysis. 30,000 square foot office building, 150 employees. You're going to save about $5,000 a year in HVAC upgrades, about $6,600 in lighting upgrades. And what do we know about an improved environment due to energy efficiency upgrades for office buildings? Well, there's several studies that give us some really good information. The McGraw-Hill partnered with the American Institute of Architects and U.S. Green Building Council and several others on a project they called the Drive Toward Healthier Buildings, and reported on this in 2014. And they asked owners of buildings to rank the top 3 benefits from a list of about 10 benefits that would deliver the greatest return on investment if they could be demonstrated to be linked to healthier building investments. And they all felt like, yeah, well, we could see that upgraded buildings could improve employee satisfaction, increase productivity, reduce absenteeism, et cetera. The CBRE organization conducted a green building tenant survey, about 900 tenants, and they responded saying, well, the biggest factors that would improve productivity for them would be access to natural light and maybe individual control over thermal comfort. And then this Lighting Europe study, we saw one that they did for manufacturing, and in an office environment, they examined 200 employees, each working at a desk, and again, they upgraded their lighting to LED lighting at a higher color temperature, and saw productivity levels rise about a little over 1%. Also saw a decrease of the number of sick days and duration of employment there as well. But wait, there's more. The World Green Building Council, on their study, Health, Well-Being, and Productivity in Offices in 2014, determined that a comprehensive body of research suggests that better indoor air quality, meaning lower concentration of CO2, pollutants, and higher ventilation rates, could lead to productivity improvements of 8 to 11%. That's just indoor air quality. Thermal comfort-wise, they saw that thermal comfort has a significant impact on workplace satisfaction, and modest degrees of personal control over thermal comfort can return single-digit improvements in productivity. In addition to that, a large owner of commercial real estate property, particularly office portfolio, they looked at 300 office properties, including, and looked at data such as, well, what are the rents, rent concessions, and lease renewal rates, as well as the building level occupancy rates, tenant satisfaction scores, energy and water consumption, green building certifications. They compared buildings that had some sort of a green building certification, the LEED, BOMA, Energy Star certification, compared to those that didn't. And they looked at this over 10 years of financial performance data over properties that totaled 58 million square feet. And they saw that, hey, for these more energy efficient buildings, rents were higher, concessions were less, occupancy rates were higher, renewal rates were higher, satisfaction scores were higher, and of course, as you might expect, energy consumption certainly was lower per square foot. So there's quite a bit of evidence on the impact of HVAC and lighting upgrades. If the utility bill will be impacted by about $11,600, as we said before, and if you look at productivity, health, and building maintenance for an office space, and again, we're saying 1% employee productivity, you saw much bigger numbers from those studies. Being very conservative is 10 times the amount of utility savings. Let's look at retail sales. I think we're going to see, obviously, the same thing here. So a 50,000 square foot retail store with 50 employees. I look at the average consumption on that square footage and how much you might save, about $6,000 an HVAC upgrade, about 50% more for a lighting upgrade. And so what impact can energy efficiency building upgrades have on retail sales? Well, Areni and Kim did a study, the influence of in-store lighting on consumers' examination of merchandise. They determined that brighter lighting influenced shoppers to handle and examine more merchandise. And then there's been other studies that showed from Colonial Park Plaza, 50,000 square foot, 72-store mall in Harrisburg, Pennsylvania, upgraded the common area lighting, saw significantly reduced operation and maintenance costs, obviously, but they also saw traffic counts increase very significantly by 1/3 merchant sales increased by about the same amount, 1/3, and more retailers opened stores there, which cut their vacancy rate. You can imagine how happy they were about that. And there's other studies, Cuttle and Branston, evaluation of retail lighting study, furniture gallery sales due to upgraded lighting increases of 35%. There was a study on Target stores in Phoenix, Arizona. Daylighting from skylights saw 15 to 25% increase in sales there. And so, you know, let's say you conservatively could see an increase of sales about 20%, and so you could compare that $15,000 total impact on the utility bill with, you know, about 6 times that on the non-utility benefit. That comes from increased retail sales and then a reduction in employee health care costs as well. How about restaurants? We're certainly aware that a reduction in operating costs is not a restaurant's top challenge in developing a profitable restaurant. Here's evidence of that, a study a few years ago, but still I think it's true today that their top challenges are, you know, making money and generating sales revenue, bringing people into the restaurant, and operating costs are a pretty low priority. And so, okay, let's say a 6,000 square foot full service restaurant, 25 employees, might save $1,500 a year on a HVAC upgrade, $2,400 a year on a lighting upgrade. And here's some evidence that what the financial impact might be in other areas. And it was Strobly and DeCastro, their study on effective ambiance on food intake and food choice showed that brightly illuminated areas promote the intake of rapidly eaten meals of greater total, and in lower temperatures, such as air-conditioned rooms, seem to have a similar effect on increasing intake of food. This would be for fast food type operations. And in the fine dining area, Lyman, who produced a study called A Psychology of Food More Than a Matter of Taste, says that warm light appears to make people more comfortable, leading them to staying longer in the location, which leads to increased food intake, whereas glaring light decreases the amount of time people spend in the eating location. And another study by Aurora and Singer called Cognitive and Effective Service Marketing Strategies for Fine Dining Restaurant Managers says that after years of fast-track eating, the baby boomers now seeking a connoisseur experience when dining out. They're seeking a time-using or social-emotional rather than a time-saving, eat-on-the-run philosophy when it comes to dining. And so upgrading lighting to give control over this, and HVAC as well, is going to make an impact on that second bucket. How much? Well, we're comparing $4,000 of impact on the utility bill with, let's say, 10% increased food sales, of course, employee health reduction, cost reductions as well. You know, in this case, about 3 times more than the impact on the utility bill, but it's still, you know, real dollar impact, either increased revenues or decreased expenses. And getting to the end here, we'll take a look at multifamily apartments. Let's say a 60,000 square foot apartment complex, that would typically be about 50 apartments. HVAC upgrades, again, might save a couple thousand. Lighting upgrades, about $1,600. And let's compare that to other non-utility savings. Where would that come from? Well, it comes from several things. It comes from higher occupancy rates, more marketable buildings, higher rents, and this is a COSAR study, which is a research firm specializing in rental properties. And of course, you have that green image, which doesn't hurt as well. And for, you know, multifamily apartments, the utility costs can be pretty significant just alone, but you can imagine that these would have even a bigger impact. Let's see if we can quantify that. And again, do our comparison of utility savings in bucket number 1. And if we assume that 60,000 square foot, 50 apartments, let's say an average monthly rent is 10% higher for those 50 apartments, you're going to see $63,000 of additional revenue. Average vacancy rate is 4.5%. That's 2 apartments. Let's say you can cut that in half, just 1 apartment. 1 additional apartment earns about $14,000, totaling $77,000 in new revenue from those energy efficiency retrofits. Of course, what the property owners are really interested in is what's called net operating income, and it's shown, the statistics show that net operating income is about 50% of gross potential rent. And so now you're comparing $4,000 impact on the utility bill with $38,000 in additional net operating income from these upgrades. So it's very attractive to the justification. Moving on to schools, hopefully this is hitting about everybody that's in attendance today one way or another. And if we look at a 50,000 square foot school, let's say 625 students, 25 teachers, you're going to again save a couple $1,000 with an HVAC upgrade a year, $9,000 in a lighting upgrade. And there's really no way to practically monetize improved teacher productivity, so we'll focus just on, first of all, just absenteeism costs due to building-related illnesses. And again, there's a number of studies. Carnegie Mellon Center for Building Performance I've cited before. They had a study, the costs and financial benefits of green buildings, and they showed pretty significant impact on sicknesses due to increased outdoor air, better moisture control, removal of pollutant sources. The state of Washington had a study, Washington High Performance School Buildings report to the legislature. They showed that improved indoor air quality reduces absenteeism pretty significantly. And there was a study in the Illinois Healthy Schools Campaign titled 2 Illinois School Districts Show Successful Indoor Air Quality Management, and they show, again, student attendance improvements after improving indoor air quality. And the way we monetize that is we could say, well, you typically see 4 sick days per school year, cost per pupil. Schools get paid for students in the seats, and if you can reduce by 1 sick day per student, that savings based upon 625 students, $30 a day, is about $18,000. You can do the same thing for teachers. There's not as many of them, and there's not as, although the cost savings is higher, and you'd see about $2,500 by improving their attendance as well due to sick days. So you're going to compare about $11,000 of utility bill savings to about twice that in reducing student absences and teacher absences due to building-related sicknesses. And that's pretty attractive, but I think there's even a far more attractive benefit to these energy efficiency upgrades, and that is from the impact on improved student performance. And there was a study again by Schneider, Public School Facilities and Teaching, Washington, D.C. and Chicago, that determined better facilities can add 3 to 4 percentage points to students' test scores. Wow. What's that worth to your school in monetary means? That's worth quite a lot, probably more than even the numbers we just looked at for better attendance by students and teachers and missed school days, et cetera. There was another study by the Mahon group on daylighting and skylighting in 3 school districts with 21,000 students and over 2,000 classrooms. There was a school district studied in each state of California, Colorado, and Washington. They analyzed the influence of daylighting and skylighting on student achievement, particularly on the Iowa test of basic skills for math and reading, as well as other tests in the other states. And they determined that students exposed to natural daylight had very significant improvements on math tests, reading tests, et cetera. And a Virginia Polytechnic Institute studies also showed that daylighting has a similar effect in classroom comfort, particularly with temperature control and good ventilation, good outside air, results in less instances of off-task student behavior. And there's studies are going on more and more in this area. In fact, in a study of 58 high school students, this was again by Marion Figueroa at RPI, in a study of 58 high school students, the difference of standard lighting at, say, 3,500 degrees warm temperatures versus blue enriched lighting at 5,500 degrees test group was measured for short and long-term effects, and they saw that that blue enriched lighting produced higher speed of cognitive performance, concentration, and accuracy. And again, studies are coming out all the time in this area, really supporting this benefit. Kind of turning our perspective here a little bit more, let me challenge you with another way to look at this, and that's a profit perspective. And what I'm really asking is, let's ask ourselves, which is easier to achieve? Lower expenses by energy upgrades, or the associated increased revenues required to achieve the same impact on the bottom line? And let me explain what I mean. Let's take the manufacturing sector that has a 5% profit margin. If you were going to do a project to save $10,000 in utility savings, it would take about $200,000 in additional revenue at 5% profit to equal the impact on profit as utility savings. And let's, say it's $200 a widget. You'd have to manufacture and sell 1,000 more widgets. And, well, that has an investment required. You might have to invest in additional production equipment. You might have to invest in more marketing and sales, either people or materials, to do that. Say the same thing in healthcare, 3% profit margin. So to save you could save $150,000 in utility savings on the one hand, or you can increase revenues $5 million. That'd be about 1,500 patient days. Which is easier? Same thing for retail, $15,000 utility savings. You want to sell 9,000 pair of jeans to equal $450,000 increased revenue and all the expense required to do that. Same thing with restaurants, $4,000 utility savings or $133,000 additional revenue, which would be about 1,300 covers or meals that you'd have to increase. And that's a great question, which is easier? And it sure seems to me that utility savings would be a lot easier than generating that additional revenue. Okay, so I hope we challenge you. I think we did, to think about, is there more impact on our facility in terms of energy efficiency upgrades than just the utility bill? And I think there is, both in actual dollar impacts, things like productivity, reduced healthcare costs, et cetera, as well as non-financial benefits like improved, getting a green building certification, making it more attractive to employees or new employees that you're interviewing, et cetera. But in the end, though, we're still going to have to do this financial analysis, comparing our energy efficiency project and probably competing with other projects to expand the facility or invest in additional people, whatever. And often we do that with what we call simple payback analysis. But what I want to challenge you to think about is maybe there's some better ways to analyze a project than simple payback. We're going to look at these three: net present value, internal rate of return, something called savings investment ratio. So let's take a look at that. Let's take a look at two projects, okay? Let's say you have a project, maybe it's a lighting project. You invest $12,000. You're going to return $4,000 a year for 4 years before you'd have to, for the life of the project. In the simple payback terms, that would be the $12,000 investment over the annual $4,000 returns. It gives you a 3-year simple payback. And compare that to project B. It's a less of an initial investment, $10,000 instead of $12,000. It's less savings each year, but it lasts a lot longer. And we do that same $10,000 initial investment divided by the annual paybacks, $2,500. We get a 4-year project payback. And for most people, when we ask them, well, which project would you put your money in? most people say, well, simple payback says project A. It's a shorter 3-year period. But the issue with that is, one is simple payback really only answers 2 questions. How long until I get my money back, and then is there an investment I should make? But simple payback has some limitations. It doesn't account for additional energy savings or monetary net benefits that occur after the payback period. So in this case, in B, it completely ignored the savings of years 5, 6, 7, and 8 as if they didn't even exist. It did so here too, but probably more egregiously here. And is there any way that we can incorporate all the savings? And we can through something called the time value of money. So let's take a look at that. And what do we mean by the time value of money? Well, consider 2 opportunities, and that's going to be evident here. You have a $10,000 investment. This is project B, $2,500 a year. And just think about that the first year. If you could obtain $2,500 today or $2,500 a year from now, which one would you want? Well, most reasonable people would say, well, I'll take the $2,500 today. And why is that? That's because we could take money today, that $2,500 today, and invest in it. It's going to be worth more a year from now. And conversely, we can say, well, $2,500 a year from now is worth less than today by a discount factor. Let's say it's 7%, and we're not going to get into how we all came up with that number. It's a cost of capital, let's say, or just some investment opportunity. You could take money to invest. Well, you could take $2,336 today and invest it at 7%, and it'll be worth $2,500 a year from now. Or conversely, $2,500 a year from now is only worth, 93% of what it does today, or $2,336. So money a year from now is worth less today than its stated value, and it gets worse and worse as you go along. For instance, in year 5, this $2,500 received at a 7% discount rate, it's only worth 71% or $1,782 to us today, because we could take that $782 today, invest it at 7%, and it'll equal $2,500 in 5 years. And if we do that same analysis over all those cash flows, we get what's called the present value of that being about $14,928. Now, we'll get a cash flow of $20,000, but realistically, it's only worth about $15,000 to us today. And if we think about, well, if we have a net present value of $14,928 today of those future cash flows, and we're investing 10, then the net present value minus our investment, is about $5,000. Now, also, we get, a $20,000 savings over time minus that $10,000 investment, a $10,000 cash flow as well. Hopefully that makes sense to you. And we can do that for Project B as well. We've done that here. And so now we have Project A, 3-year simple payback, but you have a net present value of about $1,500 cash flow of 4. In Project B, now we've also incorporated these additional cash flows or savings. Our net present value is about $5,000 and cash flow about 10. And I go back again and say, well, which project now would you put your money in, A or B? And most people would look at this and say, well, really, yeah, Project B actually is more attractive, even though it has a little longer simple payback. And again, your accountants, bean counters might like that dollar number, net present value. A lot of times, though, they like a percentage return. And so we can do that same analysis as well. And so the question becomes, what's the minimum discount rate that would make my investment in positive cash flows come out to a net present value of 0? And why is that important? Well, then any alternative investment would have to offer a return greater than that in order to be a better investment. And our concept of internal rate of return gives us that answer every single time. And so think of IRR as an annual internal rate of return that makes the present value of future cash flows equal to the initial investment. So here's an example of that in Project A, $12,000 initial investment. And what internal rate of return would we have to be to make all these cash flows equal to that initial investment? Well, we had to increase it from 7% to 12.6%. And we still get, again, $16,000 of cash flow, but now the present value is equal to our initial investment. We can do that for B too, and so we'd have to go from 12.6% to 18.6% to make all these numbers work out so that the present value would be equal to $10,000. And again, if we add that to our analysis here, you can also again see that the investment is more attractive for project B. We have this internal rate of return about 12.6%, positive net present value and cash flow, but these are all better numbers here, much higher rate of return, net present value, and cash flow on this as well. So it's another way, it's saying the same thing, only you give your accounting people that percentage number, and they compare that to, again, what we call their cost of capital, and determine, hey, if we can do better than whatever it is, 10%, then we'll fund these projects. And that's how they're doing their analysis on competitive projects, like I mentioned, so we want to be as competitive as possible. Another way to present this too, if that's a little too complicated, hey, just take that present value, divide by the initial investment, and you can say, well, we have a savings to investment ratio that's greater than 1, so we're going to save more than we invest by whatever amount. In this case, A is 1.1 ratio, B is 1.5, again showing B's a more favored investment. Now you can do this IRR analysis using Excel spreadsheet, and you can even do, if the numbers are way too high, you can use a modified internal rate of return, and there's an Excel spreadsheet on that too that you can use that. So it's very doable by the common man, or woman. Common objections here, just wrapping up here. Here's 3 big ones we often hear. Well, hey, we only fund projects with a 2-year payback, and we all know that that's not a very good metric to use, but okay, so we would reply, well, what's a 2-year payback? That's a 50% return on investment. Well, where else are you getting this 50% return on investment? The prime rate today is only about 4.25%. Yeah, okay, maybe back in 1980, and I remember my mortgage at the time was 10.4%. Well, yeah, maybe you could get a 50% return on investment on somewhere, but today that's very unreasonable. I don't know where anyone could say they could get that, and why would you require it on your existing projects? Also, hey, we've already plucked the low-hanging fruit, and well, and let's use the farm analogy. Do farmers only pluck the low-hanging fruit? No, they go to some extra effort to pick that fruit up the top of the tree using or vines or whatever, and they get 90% of it, and they're not satisfied with just 30% of it. And the last one here is pretty interesting. It says, well, we don't have a budget for this, and you really have to think about, well, what's the decision you're facing? So you could do nothing, and that costs you seemingly nothing, and you're going to use this much energy, annual consumption. Or you can invest a little bit in an upgrade, and you result in energy consumption will now be decreased down to here. And so whether you do nothing or invest in energy, you're going to still buy and use a certain amount of energy as intended. But if you do nothing, you're actually buying and wasting this amount, the difference between doing nothing and your efficient alternative. Okay, but if you do an energy efficient investment, you do have an investment there as well. So whether you buy it and waste it or pay to avoid wasting it, you're paying for it either way. So there's a cost for doing nothing. And so maybe you can find it in your budget to go from this condition to this condition and not paying for something that you don't need to pay for. So hopefully that made some sense to as well. Poll question here, this is the second one. Would you like some help from someone from Indiana Michigan Power to help you justify energy efficiency upgrades in your facility? And of course, how valuable has this webinar been to you today? And we have 5 choices there. I want to do two other things here before we come to questions and answers, and type those in the Q&A text box if you have any questions and answers. Our next webinar is going to be on Tuesday, December 6th, 1 p.m. We're going to talk about the best in energy-efficient commercial lighting. We've gone to some trade shows, particularly the Light Fair International here recently, talked to dozens of award winners, and innovation award winners, to find out why was their lighting products awarded an innovation award, what made them special, and after we did that, we still walked around the place and talked to, sought out other innovations, and we're going to share all that with you. So all that hard work we did, we're going to share that, and you will be amazed at the innovations in lighting today, brought about primarily by the advent of light-emitting diode technology, LED lighting. And so we'll look at lighting fixtures, lighting controls, and a number of things. So don't want to miss that one. It's going to be really interesting, and it'll really give some great ideas on how to improve your facility and achieve those non-utility financial benefits as well. And then next, I just want to turn it over to Jason Whitman, who's going to tell you a little bit more about 2017 Indiana Michigan Power Energy Efficiency Programs.
Thank you, Mike. A great presentation on the different benefits that are available to all of us, whether we're a customer, a trade ally, or an energy professional. I think there's a lot of good things we can take away. So our goal for these webinars is kind of twofold, right? We want to educate you no matter what your designation is. If you're a customer or maybe you're a trade ally and you want to market products to a customer, you can now offer and really speak about different benefits other than just utility benefits to your customers. So I hope you're able to gain something from the webinar. And our second goal really was to point you to our programs and our incentives that we offer at Indiana Michigan Power. So what you see on the slide here is our 2017 programs, but be mindful these are going to carry over into 2018 as well. And we've listed, most of our programs here are prescriptive, custom, new construction, and small business direct install. And all these programs offer 100-plus measures to our customers, and we do have some caps on our program. So you can, as a customer, can receive up to $100,000 in incentive rebate money in 2017. And again, that'll be similar numbers in 2018. So how do you apply? Well, we point all of our customers, trade allies, to electricideas.com/work. This will bring you right to our home page where we talk about our programs. We are able to download copies of our application, which again is all electronic. And then we also list our trade allies that participate in our program. So we kind of have a one-site catch-all that lists all these different programs. And some of the kind of differences between some of the programs are your prescriptive program does not require a pre-approval. As a customer, you can purchase, install, and then apply for the rebate. And we do that so that customers have a pretty flexible manner in which to complete their energy efficiency projects and still be incentivized as well. I'd like to also talk about, we have a new part of our program that we're going to be offering. It's an energy auditing tool library, and here we have auditing tools that your customers can check out, or if you as a trade ally would like to check out one of these tools to help do audits at a customer's facility, we offer that as well. We loan it out, and I'll be glad to drop it off and deliver it and explain how things are used as well. So that's another feature. So my contact information is here. Again, I'm Jason Whitman. There's my phone number, my email address. I encourage you to reach out if you have any questions. I'd be glad to sit with you, or if you have a customer or would just like some answers to questions about the program, please reach out to me at the number listed there in the email as well. And also point, once again, to electricideas.com/work, and you'll be able to look at our program brochures and our applications there as well. I'll turn it back over to you, Mike, and you can do any questions and answers that may have arisen.
Thanks, Jason. We do have a question here about this cost of capital concept, and let me go backwards here a few slides and address that. I think it was about, where is it here? Oops. Oh, it's backwards here. Here we go. The term cost of capital refers to the return required by investors or lenders that's enough to induce them to provide funding for an ongoing business. That's kind of the simple explanation of it. But it's required, you can also think of it as the required rate of return necessary to make a capital budgeting project, such as building a new factory, worthwhile. The cost of capital is something that's unique to each company. Financial people calculate this along with help from the outside world because the cost of capital includes the cost of debt, cost of equity. It certainly is influenced by the risk afforded by that company. And so maybe a small company that's only been around a couple of years, they're going to have a higher cost of capital typically than a large company that's been around for 50 years. This term is also known as the hurdle rate, of course, above which a project must earn returns in order to be funded. So you're going to have to go to your financial people to find out what your hurdle rate or cost of capital is. It might even be in, of course, the annual report, et cetera, financial numbers. But practically, we could say, well, if the cost of capital or hurdle rate is 10%, then you know, both of these investments would be attractive because it's 12.6% in the case of A and 18% in the case of B. But if these numbers came out to be, say, 8%, then that would be something that a company probably wouldn't be justified to invest in. So hopefully that makes a little more sense there. Let me see if there's any other questions here. I don't see any. So with that, I'm going to wrap up and have Chris end with some closing comments. Thank you for your attendance today.
Thank you, Mike. I would like to thank you all for attending our webinar today. As a reminder, presentation materials and the playback link to the recording of today's webinar will be emailed to you sometime within the next couple of days. If you have any additional questions or feedback, please do not hesitate to contact us. Thank you again for attending, and have a great day, everyone.